Welcome and welcome back to this channel. This video is to discuss hypothesis test. Hypothesis test is a statistical tool and a frequently asked question in the interview. So this video will discuss these problems in an intuitive way rather than a textbook way. The 2 sigma question is you have a strategy where your trader or quant researcher claim to have an information ratio equal to 1. But the question is that how can you test if this is true or false? Here, true or false question is from statistical perspective. There's no 100% false or 100% true in the real world. If you think something will happen for 100% sure or 0% sure, that means your thought might be wrong. So before this information ratio problem, let's start from an easier one. If there is a person A and person A told person B, hey, I have a coin and this coin is a fair coin, how does person B can verify if A is correct or not? From intuition, let's go straight to do some experiment. And if the result of such experiment is very rare to see, it seems that this is not a fair coin because the probability of such experiment result is really small or almost impossible. Here I do not want to mention the statistical terminology such as p-value, type 1 error, type 2 error, reject the null hypothesis, and etc. The interview is mainly to verify if you have the intuition. Let's say, okay, assuming that this coin is a fair coin, which the probability of the head and the tail are both equal to 50%. Then we will test and toss the coins 10 times. Here we should toss more, like 1 million times or 10 million times, but for simplicity case, for calculation, we toss this only 10 times in this case, just for an example. So if we got a result like 8 heads and 2 tails, from intuition, it seems not a fair coin because the number of heads is far more than the number of tails. So if it is a fair coin, the number of head and tail should be 5 head, 5 tails, 6 head, 4 tails, or 4 head, 6 tails. The probability of such experiment result is called p-value. So what is p-value? P-value is the probability of experiment result, assuming that the null hypothesis is correct. So here in this case, the result probability is choose 2 from 10. And 2 tails, so 1/2 powers to 2. 8 heads, then we have 1/2 powers to 8. Then we quickly can see this probability is less than 5% because choose 2 from 10 is equal to 45. Denominator equals to 2 powers 10, which is 1024. So nominator 45 is less than 50, and the denominator 1024 is larger than 1000. So the final probability is less than 5%. In an intuitive way, less than 5% means such experiment result is very rare, looks rare, like CryptoPunks. So the assumption that this is a fair coin might be wrong. And note that here I am saying it might be wrong, not it is wrong, because we do have the case that this coin can be a fair coin, but it is just a very rare case, as this is no 100% for sure happened in the real world. Let's go back to the information ratio problem. Information ratio is the average return divided by the return's standard deviation, usually by annual information ratio. So let's model the return. Return is a stochastic process where it deviates from the average return following a normal distribution. You can model it as any distribution that makes sense to you. For example, you can model it as a t-distribution with a given degrees of freedom. It is possible for us to get the historical data for return, and we can count the number of profitable days versus the whole number of days. So if the probability is larger than some number, it may be useful for us to verify the information ratio And let's do it in this way. So now we want to express the probability of profitable days in formula. The probability of return larger than 0 based on our modeling is actually the probability of z larger than a negative information ratio. And then the problem solved. So here we need to use the daily information ratio, and there is a trick to transfer this one. So usually information ratio published for clients is annual one, and here we need to use the daily one. So we know that if the 1-day return is 1%, 10-day return will be 10 times 1%, assuming no compounding. If the 1-day standard deviation is 10%, the 10-day standard deviation is the square root of 10 times 10%. The reason is that a linear function, the reason why standard deviation is a linear function of a square root is that, let's see a stochastic differential equation. So to make it simple, let's say dx of t equal to sigma times dw of t, and x is a normal distribution with a mean equal to x of 0, and a variance, which is very important here, is a sigma square root of times t. So the variance is a linear function of t, so standard deviation is a square root of a linear function of a square root of t. So if the annual information ratio is equal to 1, then the daily information ratio is 1 divided by square root of 252 trading days, or 365 trading days if it is cryptocurrency. And then we use the previous relationship, which is probability of profitable days is equal to the probability that z is larger than -1 over square root of 252. And then let's do an approximation here. Square root of 252 is close to square root of 256, and square root of 256 equals to 16. So the final answer will be the probability z is larger than -16. 1 over 16. So recall that z is larger than 0 is 50%, and then the -1 over 16 is a little bit left apart, so the probability is a little bit larger than 50%. For example, maybe 51, 52, 53%. So the probability of profitable days is a little bit larger than 50%, which means that almost in every 2 days, you have 1 day for profit, 1 day for loss. A little bit larger than that for winning ratio, but around 50%. And let's move to a more frequent perspective. More frequent you trade, if your average return does not change, usually information ratio will be higher due to central limit theory. For example, if the information ratio is equal to 10, I want to calculate the probability of the winning in every minute. So let's first transfer the annual information ratio to minutes level, and we got 10 divided by square root of 252 times 24 hours per day, or 9 hours per day, whatever you want, and 60 minutes per hour. And you will see this ratio is very, very close to 0, which means that this probability will be a little bit larger than 50%, not exactly equal to 50%, but a little bit larger than that, which means that in every 2 minutes, you got a 1 minute loss and a 1 minute for win. And you don't need to your winning ratio like 9%, 90%, or 80%. You don't need to that. So that's all for today's video. Hypothesis test mainly focus on your intuition. Do not just memorize those technical terms like p-value, rejection of hypotheses, type 1 error, type 2 error, t-distribution, and extra. Those terminologies do not work and easily get you confused, and the interviewer do not need this terminology. So start from the intuition and get a result that makes sense. Thanks for watching this video, and if you like my video, do not forget to press the like button and subscribe my channel. Thank you.